Hi and welcome to the demo of SynVisio, an interactive web-based Synteny analysis tool developed at the Human-Computer Interaction Lab at the University of Saskatchewan. SynVisio offers three basic kinds of visualizations: a linear bar plot, a height plot, and a dot plot. Now, before we go into the actual demo, SynVisio has been developed exclusively for the Google Chrome browser, and a lot of experimental features might not work in other browsers, and so we offer only complete support for Google Chrome. So SynVisio basically runs on the output of MCScanX. MCScanX is a very popular Synteny detection and collinearity detection toolkit, and often requires basically the blast output and the simplified GFF file to generate a collinearity file, which is what we'll be needing on SynVisio. So again, to reiterate, SynVisio requires two main files to run: a simplified GFF file that was fed in as an input to MCScanX, and the collinearity file that was generated as an output by MCScanX. Now let's go into the actual dashboard to see a couple of sample results. Now for the purpose of demo, I've already loaded up the Brassica napus genome, and you can see here the MCScanX parameters that were set when this tool was run and the share of collinear genes. Now all of this information is directly coming from the collinearity file that you uploaded to the tool and is not generated in SynVisio. The only thing SynVisio does is it visualizes the results that have already been pre-generated, so there's not a lot of actual processing happening on the browser. So in the filter panel, you can actually select the source and the target chromosomes. Now this is a linear analysis, so we'll have a source and then a target. So as you can see, I've selected BN1, 2, and 3, which is the first, second, and the third chromosome for Brassica napus, and in the target we have 11, 12, and 13. If I click on go, you can see that the results are available. Now this is the default mode in which SynVisio works. It's a dashboard that has both the linear bar plot and a dot plot, and a filter panel on the side that which you can sort of filter out links that you're not interested in. So to give you a general overview, in the bar plot, you can click on the source, and that sort of isolates only the links that emerge from that particular source. So let me reset that and replay that for you. So if I click on the marker over here, you can see that the links that emerge only out of BN1 are highlighted and the rest are all hidden. And you can see the same effect is also there on the dot plot. So you only see the links for which Brassica napus 1 is the source, and all the links that are other than that are hidden by default. Now the filtering can also happen from the target side, so you can just select BN11 and then we only show the links that emerge out of BN11 and the others are hidden. So it's a nice tool to play around with. You can select different regions and see different links emerging out, and you can see the same thing also filtering out on the dot plot over here, and it can help you in detecting patterns that you might have been interested in. So let's reset that. Now, of course, it works even on the dot plot, so the same effect happens over here, and you can also do it on just the sources alone. So what we have over here is the general whole genome level. Now let's get into the next level, which is the chromosome level. So to do that, I need to select the source and one of the targets. So let me select BN13. So the source I have selected is BN1 and the target I'm going to select is BN13. And once I do that, we enter the chromosome mode, which is where just a single set of chromosomes is selected. You have both the whole genome linear bar plot and the dot plot, and both these plots are now also zoomable, so you can zoom in and then interact with them. Hovering over a link also gives you information as to what type of a link it is. A blue link represents a regular link, and you also get the e-value, the score, and the count. And a red link means that the entire genomic block was flipped. So before we go further into that, let's go back to the previous mode and further explain how this filter panel works. Now you can see that we have both the count, match score, and the e-value. Now let's say I'm only interested in links that have a higher count or a higher match score. You select that, and then I move the slider, and that sort of filters the links that have a higher match score. So if you're interested only in links that have a higher score, you can just filter them out. Now the same thing also works for e-value. So let me reset that, select e-value, and then once I do that, I only get links have a e-value that's higher or equal to the value that's shown here. And if we just slide that down, that shows all values, including the ones that have an e-value of 0. Now you can also go ahead and select a different set of source and target chromosomes. So let me just select BN6. Now, of course, Brassica nippus has a lot of duplication internally within it. So the first 10 chromosomes are then duplicated again in the next 9 chromosomes. And so you see a lot of syntenic blocks over here. And of course, you can filter through them and then look each one of them up in a deeper fashion. Now let's go into the whole into the chromosome mode from the whole genome mode. So if I select the source and then I select a target, I enter the chromosome mode. Now the same sort of filter also works with this. You can see certain links are being added and then certain links are being deleted. Now let's say I want to explore one particular block in a much zoomed in way. So I simply double click on that particular link. So I just hover on top of that and then I double click on that. And then what that does is it hides all the other links, only highlights that both in this and in the dot plot, and then opens up the actual genes in that particular block. And you can explore this region further. And I can use my mouse and I'm scrolling my mouse wheel to zoom into the plot. And then I can hover over each of these links to actually see what's the source and the target gene ID. So that's a block level view. Now let's reset back. And because the one that I had clicked on was an actually direct block because it's blue in color, you can see that all the links are directly linked. And now let's say I pick an inverted block where the links are all reversed. I can actually use this new button over here that reverses just the bottom strand. And so that gives you an much easier look on how the genomic region looks once it's flipped. So that was the original. This was the original. And once I click on that, that flips the whole region around and you can then zoom in and then investigate each of them. Because you have these 4 buttons on both sides which you can use to move just the top strand or the bottom strand selectively. And you can of course use your mouse to zoom in, zoom out, and then pan the region as you want. Now this even works even for other regions, so I can even select it on the dot plot. So let me just zoom in and let's say I'm interested in this. I double click on that and that opens the block view just for that, and that's a huge chunk of syntenic region that's quite similar. So I can of course click on resetting the block view and that just takes me one step up. I click on reset and that just takes me back to the whole plot again. So the other feature we have is a snapshot store. Now what this basically does is, let's say you're investigating a particular gene and then you've filtered out and refined your plot and you want to revisit that at some future point, you can actually take a snapshot of that particular visual state. So let me demonstrate that. So we have this on the screen and let's say I selected something and I want to revisit the same thing. I just click on this and that sort of stores the current visualization on a snapshot in here, and I can revisit at any point in time. So let's say I do something, I select BN4 as the source, then I select BN16 and I double click on this, then I embed the block. So now I'm 4 steps in. I can just click on snapshot store and that again stores this particular state of my interaction in the snapshots store. Now I can go back to what I was doing previously, or in fact I can just do something else. Let's say I want to explore 7, 8, 9 and then 17, 18, 19. So I click on that, that opens up a new panel. I take a snapshot of that. I click on this, I take a snapshot of that. Now I can easily go back to what I was doing before. If you remember, this was the first snapshot we took. I just clicked on that and then it took me just back to the whole visualization again. I can click on 2, which was something that I had visited before and I took a snapshot of. I click on 3, I click on 4. So the snapshot feature is basically if you have refined your data set and are looking at something interesting and you want to look at it again and revisit it, you can just take a snapshot of it and then store it and then look it up even for further reference. And this feature can be particularly useful, especially if you're trying to compare 2 different set of genes. So say for example, I've selected BN123 and I take a snapshot. Now I deselect that and then I select 456 Then I click on go, and then I take a snapshot. Now I can just go back and forth between them to sort of just compare how both these plots were. So that's just the dashboard part of view. Now let's say you're only interested in looking at just the linear bar view or just the dot plot. You can actually just go select that. So let me just switch to configurations. Now by default it's selected as the default dashboard in single analysis. Now again, you have to remember that this is just a two-way analysis, which is why we have selected single analysis. So let me click on dot plot or a linear plot. Let's go with dot plot. Now switch back to the dashboard. If I click on go, you can see that just the dot plot alone is shown. Now I can again do the same thing. I can just click on linear plot, and you can see that just the linear plot alone is shown and the dot plot is hidden by default. Now again, all the other features are the same. You can select source and target chromosomes, zoom into that, and then click on a block view, and then invert that, and then inspect the genomes as in when you need, depending on what you're trying to do. Now again, let's go back. The other tool that we have, which is again a big point in this, is the multi-level analysis. Now in this feature, we are trying to compare sequences that are more than just two. So it's not just a source and a target. It can be a source with two different targets or three different targets or two different sources and multiple targets. And the best sort of visualization for that is a high plot. So if you want to visualize your Synteny through a high plot, just click on multi-level analysis, go back to the dashboard, and you will basically have sources to select here. So as you can see, we have only two sources now, which is again sort of like a single analysis. So let's go ahead and add one more source. So let me just select 11, 12, and 13. So I click on go, and you can see that I now have a high plot with three different sequences. One has brassicanippus 1, 2, and 3. The second sequence has chromosomes 11, 12, and 13, and the third sequence has chromosomes again 11, 12, and 13. Sorry, that's my bad. Let me just deselect that and select something different. Yeah. So there you go. Now if I click on this, that adds the chromosome labels, and you can see that each of the chromosomes are annotated depending on which region they represent. Now again, you can see that this particular arm is quite bigger than this. That's because there's just more genomic information in this three chromosomes compared to BN123. Now if you want a proper plot, you can of course click on normalize length, and that normalizes the three plots so that they have a uniform length, and that makes your plot look much better. Now we have done that. Again, I can toggle that, and that shows the actual genomic length, the absolute length, and that's a normalized length. Again, you can toggle the chromosome labels on and off, and you can of course even increase or decrease the number of sources. So let's say I just want two sources. I can just go back to that, and that's just a direct link between two of them, and I can even increase the number of sources. Let's say we have three, and then let me just go one more step and then add 9, 10, 11, and 6, 7, 8, and click. Now you have 5 different regions all being compared with, of course, just its two nearest neighbors. Now let's just go back to a 3-level high plot. And the other feature we have is you can click on any one particular sequence, and that sort of just highlights all the links emerging out of just this. So all the links that BN3 is syntonic to are sort of colored in the same color. So you can see that a large chunk of BN1 is duplicated in BN15, and it's also duplicated in BN13, and there's even a couple of blocks that are also present in BN14. So this can be much more easy for you when you're trying to explore just how your data looks like, and you just want to do a three-way analysis. And of course, the same snapshot feature again works even for this. That's again common throughout the tool. So let's say you have something different. You can take a snapshot of that. That's again stored, so you can switch between both of them depending on what you're trying to do. So, and the final feature that I wanted to show was that you could actually upload your own collinearity files. Now, I've also loaded up a bunch of files just for demo purpose. So we have the brassica neighbors file, and we have wheat and also the HG38 versus chimpanzee. So that's a direct syntenic relation between humans and chimpanzees. And of course, let's select a single default dashboard because that will probably give you a much better view. So you can see I've selected all the human chromosomes in the source and all the chimpanzee chromosomes in the target. Let me just click on go, and that shows you all the links that are common. So you can pretty much see that there's quite a lot of syntenic regions that are quite common between humans and chimpanzees, and you can of course use the filter to filter between them, and then click on any one and then look that up further if you want. So that's the basic functionality. Now the other feature is that apart from these sample files that we have loaded up here, of course you can do any sort of analysis. It can just be brassica and napis against itself, or rice against corn, or tail cress against grapevine. It can be any sort of analysis. And so to facilitate that, we have added a feature where you can upload your own collinearity file. So of course you can just load up your MC-ScanX file and GFF file. And we also have a feature where you can actually annotate your charts with additional tracks. So let's say, for example, I select, in this case, let me just select brassica napus. So I select the collinearity file, then I select the GFF file, and I select a track file. So in this case, I've already generated a gene count, which is basically just a bed graph format file, which just has the chromosome ID, the start, the stop, and the scalar value that you're trying to represent. So I click on that. I have both the gene count and the gene density. So let me just show the gene count for now. Click on that. I click on upload. And once the files have been uploaded and processed on the UI, it shows me that it's complete. So all I have to do is just head over to the dashboard and I can actually see that. So the tracks can only be viewed in the dot plot and the linear plot. We don't have support for the default dashboard because we thought that's just too much information on the screen. So let me just click on dot plot. I go back to the dashboard. I select BN1, 2, 3, and I select, let's say, 11, 12, 13 vision syntenic regions. Click on that. I click on toggle tracks, and you can see a heat map coming up on the side too that shows the gene count in that particular region. And of course, I can have the tracks in different representation. So I can select a histogram, a line, or a scatter plot. So let me just select a histogram, go back, and you can see the tracks are now a histogram. Of course, I can toggle them on and off. So let's say we have a linear plot and it's a histogram. Select 1, 2, and 3. And you can see the tracks on the source and the target. The other types we have is a line and a scatter plot. So that's just a regular line chart. And we have a scatter plot, which also looks pretty much the same. Yeah. So in a gist, that's basically all the different features that we have in MC-ScanX. And of course, this is still a work in progress. So we will be working on adding more features in future.